Today we are going to learn about prime factorization. Prime factorization. A prime number is a whole number that has exactly two factors, one and itself. So prime number can only have two factors. Our next definition is a composite number, which is a number greater than 1 with more than two factors. So anything that's not a prime number is going to be composite. Then we have a factor tree, which is a diagram that can be used to find the prime factorization of a number. Our last definition, prime factorization, is every composite number that can be written as a product of prime numbers. And then we have a little star. Whole numbers are either prime or composite. 0 and 1 are neither prime or composite, so that's just kind of a side tip. 0 and 1 are neither prime nor composite. Let's do an example. State whether each number is prime, composite, or neither, and then we're going to explain. So we have this number 35. We know automatically that 1 and 35 are factors, because if it's prime, it's going to have a factor of 1 and itself. Then we got to see, does something else divide into 35 to make it a factor? Yes, we know that 5 times 7 are factors of 35. This right here, what we just created, is called a factor tree. When we get a prime number in our factor tree, we want to circle it so we know that we are finished with that branch. So factors of 31 are 1, 5, 7, and 35. So it cannot be prime because it has more than two factors. It has 4 factors. And that means that it is composite. And explain why. Since 35 has more than two factors, it is a composite number. And that would be our explanation every time that we find a composite number. Let's try 17. We know that factors automatically for 17 are 1 and 17. Is there something else that will divide into 17 evenly? Our answer is no. So that means the only factors of 17 are 1 and 17. That's the end of our factor tree. So is it prime, composite, or neither? Well, it's prime because it only has two factors. That's our explanation that we're going to write down. Since 17 has exactly two factors, it is a prime number. Let's move on to our next example. Texas has 254 counties, more than any other state. What are factors of 254, and is 254 prime or composite? And then explain. So let's set up our factor tree. What two numbers go into 254 evenly? Well, we know 1 and we know 254 because it's always 1 in itself. Then off of 254, because it's even, we know that 2 will always go into any even number. And so we could say 2 2 is a prime number, so we want to circle it. And if we do not know how many times, we could come over here to the side and say 254 divided by 2, which is 127. So that means we'd put 127 here. And then we would look at this branch and see, is there any other number that will divide into 127 evenly? And our answer is no, so we can circle it because that is a prime number. And we've got to decide, is it prime or composite? Well, did we go past this first branch? If we didn't go past this first branch, it would be prime because that means it only has 1, 2 factors. But in fact, it has 1, 2, 3, 4 factors, therefore it is composite. And I would like you to write the explanation for this, and we will go over that tomorrow. So push pause now. Now I would like you to do the factor tree of 120 on your own, and then press play when you are finished. This is what you should have gotten on your factor tree. And then let's talk about prime factorization. So we have this thing called expanded form. That means we take all of our circled numbers, 2, and we multiply them times each other. So 2 times 2 times 2 times 3 times 5. So our prime factorization of 120, we want to combine all of the same numbers. So we have a 2. How many 2's do we have? 1, 2, 3. We would put the 3 in our power. So 2 to the third power, because remember our exponent says I have 3 of what number I'm on top of. I have 3 of whatever number I'm on top of. So I have 3 2's times 3 times 5. And this is how we would formally write the prime factorization of a number. So now we have negative 70. We can take the prime factorization of a negative number. What we want to do is we want to just say we multiply the number we are given times a negative 1. We would circle that because negative 1 is prime, and then we would just factor 70. So I would like you to factor 70, finish this factor tree, and then write it in expanded form and write it in our prime factorization notation, and we will check that tomorrow in class. So please press pause now. And our last question, a mockingbird has 28 different songs it sings. Generate an equivalent expression using prime factorization for the number 28. So that means it just wants you to take 28, and it would like you to create a factor tree. And then at the end, you're going to put so 28 equals, and you will write the notation combining all of the numbers. Let's do this together just to make sure that you have it figured out. We can say 4 times 7 equals 28. 7 is prime, so we want to circle it. Then we have a 4. 2 times 2 equals 4, so we want to circle those 2 because they are prime. That means that we have a 2 times a 2 times a 7. Therefore, we have a 2. How many 2's do we have? 1, 2. We have 2 squared times 7. That is our prime factorization. Now I would like you to answer the summary questions 1, 2, and 3. And then if you have a question of confusion, something you do not understand, please write it there. Or you need to come up with a problem for your table to solve.